All right, welcome to The Explainer. Today, we're going to talk about a tool that can totally change how you tackle calculus, turning what feels like impossible problems into, well, surprisingly elegant solutions.
So you see an equation like this, and yeah, it looks pretty intimidating, right? This is a second-order differential equation, and for, generations, solving it meant pages and pages of really careful manual calculations. And of course, there was so much room for error.
But what if I told you that's pretty much the world we live in now? This is exactly where computational tools just completely change the game. They turn these mathematical mountains into, manageable molehills.
And the tool we're going to focus on is GNU Octave. We're going to see how this really powerful and free piece of software can act like a digital co-pilot, helping you and me navigate the super tricky terrain of advanced math.
Okay, so let's get into it. At the very heart of why Octave is so powerful for calculus is something called the symbolic toolkit. And I'm not kidding. When you see it in action, it can feel like actual magic.
Just look at the contrast here. On one hand, you've got the formal first principles definition of a derivative, the dense theoretical stuff from the textbook, and on the other hand, the simple octave command that does the exact same thing in an instant. It's a perfect translation from theory to tool.
And it's not just for derivatives, not by a long shot. This toolkit is the whole shebang. It handles the core pillars of calculus. We're talking limits, integrals, solving equations, all with these simple, intuitive commands that just take all the grunt work out of the process.
Okay, so crunching the numbers is one thing, but where this stuff really comes to life is when you can actually see it. Abstract formulas can be tough to wrap your head around, but a picture really does tell 1,000 words.
Check this out. With just 3 simple lines of code, an abstract idea like sine of x stops being just symbols on a page. We just tell it to create a bunch of x values, calculate the y for each one, and bam! The plot command instantly gives us this clear, tangible wave we can actually look at and analyze.
But why stop there? Why stay flat? We can easily jump into 3D. Using a command like surf, we can build an entire landscape from an equation. This lets you develop an intuition for a shape, like this paraboloid, that just looking at numbers on a page could never give you.
And this is where you see the pure creative power, right? You can take these parametric equations that, let's be honest, look like a total mess on paper, and with a simple plot command, you turn them into this beautiful, intricate piece of mathematical art.
So this visual power, it's not just for making pretty pictures, is it? No way. It's absolutely crucial for super practical things, like optimization. The whole process of finding the highest peaks or the lowest values of a function.
If you were to do this by hand, it's a whole ordeal. It's this super rigid, multi-step process. You have to find partial derivatives, solve a system of equations, and then run another whole test just to figure out what kind of point you've even found.
But remember that bowl shape, that paraboloid we just looked at? Well, we can just tell Octave to run through that entire optimization process for us.
And boom, there's your answer. And the crucial part here is that Octave doesn't just spit out some coordinates, it does the whole analysis and gives you the definitive classification. It's a local minimum. All those complex steps are just done.
And when you plot it, you get that aha moment. It's the visual proof. It's like having a GPS for your mathematical map that doesn't just give you coordinates, but puts a big red pin right on the lowest valley for you.
Okay, so now it's time to go back. Let's circle all the way back to that scary-looking problem from the very beginning. Let's tackle those differential equations head-on.
So, this is a non-homogeneous second-order ODE, and trying to solve this by hand, oh man, it's a real beast. It requires a specific, tricky technique called variation of parameters, which involves something called the Wronskian and some very messy integrals. But in Octave, with the symbolic solver, that's it. That's the entire solution. The whole complicated, multi-page mess just boiled down to one single, clean line of code. It's incredible. And don't forget what's happening behind the scenes here. That one little command is doing all the heavy lifting for you. It's finding the homogeneous part, calculating the particular part with that tricky method, and then putting them all together. This saves so much time, and just as importantly, it massively reduces the chance for human error. And that, right there, is the real point of all this. It's the big takeaway. By automating the tedious mechanical side of calculus, tools like Octave free up our most valuable resource, our minds. We can spend less time just crunching numbers and more time exploring complex systems, testing out ideas,
and really focusing on what the math actually means. Thanks for watching.